In this video, I'll demonstrate how to view and compare file contents from the shell. Here in the shell, I'll begin by typing pwd, print working directory. Here I can see I'm in the /userfiles/sales directory. If I type ls, I can see that there are two files here, 2013 sales and 2014 sales. To view the contents of a text file in Linux, I can use the cat command. I'll type in cat space 2014 sales and I'll press enter. Here I can see the contents of that file. I can also use the tac command, that's TAC, to view the contents of a file in reverse order. Notice it's the reverse of the cat command. If I press enter, we can see, in fact, now the first entry in our output was the last entry in our previous output when we used cat. So we can use cat to view the contents of a file or tac to view it in reverse order. We can also use the more command to view the contents of something and then to stop after the first screen full of output. For example, I'll type more/var/log/messages. This is the system log file. When I press enter, I can see that it stopped. In the bottom left, it says more 0%. It stopped after the first screen full. So what I could do is use my spacebar to go through screen by screen and look through the output. But notice I cannot go back up through the output if I skipped by something too quickly. I'll press Q to quit out of that. We can use the less command, LESS, to do very much something that's quite similar. So I'm going to type less space /var/log/messages. But what's different with less versus using more is that after it stops for the first screen of output, I can use my arrow keys to go line by line down through the output, or the up arrow key to go back up through it if I missed something. With more, we don't use the arrow keys to go up and down through the output, but with less, we can. I'll press Q to quit that. I'm going to use cat to display the contents of the 2014 sales file, as well as the other file that's there. That would be the 2013 sales file. The files are similar, yet not exactly the same. There is some different content. So what I'm going to do, instead of manually determining the differences, is I will use the diff command to show me the difference between those two files. So I'll type in diff space 2014 sales space 2013 sales. When I press enter, it only shows me what's different. And I can see here the first part of the output of the diff command is telling me that in the file to the left in my command line syntax, now that would be the first file I'm comparing, 2014 sales, there is an entry for the South region for Dana Powell in Q3. And in fact, we can see that that is part of the output up here from the 2014 sales file. But if we were to take a look at the 2013 sales file down here, we don't have an entry for Dana Powell in Q3. So the little arrow pointing is showing me the direction or which file the difference is in. We also have the same kind of listings for Julio Chavez and another one for Dana Powell in Q4. Those entries do not exist in the 2013 sales file, but they do exist in the output above from the 2014 sales file. So we can use the diff command to show us the difference between files, whether they're configuration files and we want to see any changes that were made, or it could be a data file such as what we're working with, or maybe even a log file. In this video, we learned how to view and compare file contents from the shell. In this video, I'll demonstrate how to use relative and absolute paths. In Linux, at the command shell, we can type pwd to see our absolute path. In other words, our current position within the file system hierarchy. So I can see here that we are in the /userfiles/sales directory. If I type ls, I can see that there are two files here. To view the contents of one of them, I'm going to use the cat command, and I want to view the contents of the 2014 sales file. So my command is cat space 2014 sales. We can see that it does show us the contents of that file. However, if I were to use cd space ... to go back one level in the hierarchy, which we can verify with pwd, indeed, we can see we're now in /user files. If I were to use my up arrow key and if I were to try to run the cat command once again to open up the contents of the 2014 sales file, it fails. That's because we are no longer in the current directory with that file. So the relative path no longer works. What I could do is reference the full path. In other words, I could say cat /user files /sales and then put in the name of the file. This is the full absolute path to that file. That works just fine. But bear in mind, once again, if I type pwd, that we are in the user files directory. So another way we could work with that file in the sales directory is we could simply say cat sales /2014 sales, because we are already in the user files directory. And if I press enter, we can see in fact that it did work correctly. So there are some shortcuts, as we see, to move around through the file system, including cd ... means previous subdirectory in the hierarchy. We can now see that we are in the root of the file system after having typed in cd ... We can also type cd space tilde to go to our home directory. I'll verify this by typing pwd, and in fact I am in the root home directory because I'm logged in as user root. So the tilde symbol we can use in a path to refer to a home directory. For example, I might type ls space tilde /downloads just to see what's in the downloads folder in my home directory. And we can see the returned output shows us, in fact, the files in that location. In this video, we learned how to use relative and absolute paths. In this video, I'll demonstrate how to create aliases and links. Aliases are a great time saver when you work often at the Linux command line. We can use an alias or a name of our choosing that will execute a longer, more complex command. For example, consider the ifconfig command, which shows my network interfaces. What I'd like to do is only display a specific interface, so I would type ifconfig and then I would put in the name of the specific interface. But I want to take it further. I only want to display the line that has the IPv4 network information. So what I can do, using the up arrow key to bring up the previous command, is pipe the result of ifconfig to my grep filtering command. So I'll grep, and then I tell it what I want to include, which in this case are lines that have the word inet. The problem is it also returns the line that has inet6. That's the IP version 6 addressing information, and I don't want to display that. So I'll bring up the previous command again, and I'm going to pipe a second time to grep, but this time with grep I'll use the -v to exclude certain lines, in this case, lines that have inet6. Now we can see we have the desired result. The problem is that's a bit more of a longer, complex command, and if I need to use it often, I'm better off creating an alias that executes that command. I'm going to bring up that previous command with the up arrow key again, and I'm going to go to the beginning of the line. To create an alias, I use the alias command. I want my alias to be called ipadd, as in IP address. Then I'll type in equals, and I'll use single quotes to surround my entire command that I'm building an alias for. So now I've created an alias called ipadd. This means I can simply type in ipadd and it runs my command. But bear in mind that that alias is only in existence while this shell is open. If I want to make that persistent, I would add the alias statement to my bash profile script so it would execute every time I would log in. We can also build links in Linux. We can build hard links and we can build soft or symbolic links. We'll start by working with hard links. I'm going to type ls-l. In the current directory of sales, there are two files, 2013 sales and 2014 sales. What I'd like to do is I'd like to make a link to the 2014 sales file, and I want the link to be in my home directory somewhere for ease of access. I don't want to have to come to this subdirectory to get to the 2014 sales file. So what I'm going to do is I'm going to use the ln command. ln stands for link. What I'd like to do is I'd like to build a link to the 2014 sales file, and I want to put that link, the hard link, in my home directory, so /documents, and I'm going to keep the file with the same name. It's going to be called 2014 sales. So my command was ln space the source file, in this case 2014 sales, space, and then the path and name of the link that I want to create. Now, if I were to do an ls-li, so a long listing along with inode information, I can see that the 2014 sales file uses an inode number of 104.303.856. But what's an inode? Well, the way that Linux tracks files in the file system is through an inode. The inode contains metadata about the file, like the owner of the file, date and creation timestamps, along with the permissions for the file, and so on. It also has links to the data blocks on disk where the file content really resides. So the inode is metadata about that file system entry. When you build a hard link, which we've done, you are creating another file name in the file system that points to the exact same inode as the original file. You'll also notice in our output that in the link count column we have a value of 2. This means that we've got the original file 2014 sales and we've got another hard link somewhere that's pointing to the same inode. Although technically there really is no concept of the original file. So if I delete the file that we had to begin with, the hard link would still work. The inode isn't removed until the last link to it is deleted. So what I can now do is I might, for example, use the cat command in my home directory under Documents to work with the 2014 sales file, and it works just fine, as you can see with the cat command. I'm going to do an ls-li of my home directory in the Documents folder, and if we take a look, we can see the 2014 sales file is there. That's the link I created. Again, in the link count column, it has a number 2. Notice the inode number it's using. Begins with 10430. Well, that's interesting. That's the exact same inode number as the original file we started with, and that's the point. When you build a hard link with the ln command, you are simply making another reference in the file system to the same inode. But we can also build soft or symbolic links. They're even sometimes called symlinks. We do this using the ln command, but with the -s switch. The difference here is that when you build a symbolic link, the new link gets its own inode. It doesn't point to the same inode as the original file, as is the case with hard links. It gets its own inode. So I'm going to build a symbolic or soft link. I'm going to type ln space -s. I want to build a link to the 2013 sales file in the current directory, and I want the symbolic link to reside in my home directory under Documents. I'll keep the same original file name of 2013 sales. Now, if I do an ls-li in the current directory, notice for the 2013 sales file in the link count column, it still only says 1. Well, that number only increments when we build hard links. It does not increment when we build soft links. Also, take note of the inode number. For the 2013 sales file, it's 10430.3852. What I'd like to do is an ls-li of my Documents location in my home directory. Notice the 2013 sales file is a symbolic link, but notice it's got its own inode number, which means it can have a different owner, a different owning group, different permissions, and so on. Because things like the owning user, the owning group, and the permissions are metadata that are stored within the inode. In this video, we learned how to create aliases and links. In this video, I'll demonstrate how to customize the Born Again shell. The first thing we might want to customize is our command prompt. This can be done by setting the ps1 variable. To set the variable, I would type ps1 equals, and then in double quotes, I would determine what I want my prompt to display. What I've got in the double quotes in my example within square brackets is \d, which will display the current date, followed by a \u, which will display the current logged in username, and then a \w, which will show the current working directory. I also want it to have a dash and a greater than sign, which looks like an arrow. When I press enter, the prompt changes, and indeed we can see it's got the date along with the username of root and the current working directory, which is my home directory, so it shows up as a tilde. But this is only good while I'm in this shell. If I want this to be a permanent change to my prompt, I would add my ps1 statement into one of my startup scripts, such as my bash profile script in my user home directory. We can view environment variables in Linux by typing env. Here I see my environment variables along with their values. For example, there's an environment variable called lang for language, and I can see the value of it after the equals sign. We can display back the variable value by typing echo, then putting in a $sign, and then the name of the variable. So my command in its entirety here is echo space $lang. When I press enter, it returns the value within that variable. We can also build our own custom variables. We might need to do this if we have a script or an application that needs to see a specific variable value. Let's say, for example, that we wanted to build a variable called cost center, where in it we store the city name for our cost center. Perhaps we have a script that would depend on that. So to build a variable called cost center, I would simply type cost center. It doesn't have to be uppercase, but most variables in Linux are uppercase. So I'm typing in cost center equals, and here I'll type in a double quote with the name Toronto, and I'll close the double quote. Now I can verify that that variable exists by typing echo space $sign cost center. And indeed, it returns the string Toronto. But if I were to start another shell, so I'll type in bash to start a subshell within our first one, and that's pretty much what happens when you execute a script. Now that I'm in a subshell, if I once again echo $sign cost center, you can see that it returns nothing. And that's because by default, when you build a variable, its scope is such that it only works within the current shell. So we're going to change that behavior. I'm going to type exit to go back to my previous bash shell. And here I'm going to export the cost center variable by typing in export space cost center. When you export a variable, it's available in subshells. To see if this is true, let's type bash to spawn another subshell. And once again, let's echo the cost center variable. Here we can see it now returns Toronto because we had exported that variable. We can also use the setenv command to create variables, but that only works in certain shells. Here, I get an error that says command not found. That's because the setenv command to set environment variables works in a C shell, but not here in a bash shell. So I'll start a C shell, because I know it's installed, by typing in csh. Now if I were to type in setenv, it shows me my environment variables instead of giving me an error that states the command cannot be found. We can also use the setenv command to create variables. So I'm going to type setenv, then I'm going to follow that with the name of the variable I want to create, which in this case is going to be DEPT code for department code. That will be followed by a space, after which I will then type in the value of the variable within quotes, in this case HR. So I've now got an environment variable called DEPT code that has a value of HR. We can verify this by typing echo space $DEPT code. And we can see it returns HR. In this video, we learned how to customize the Born Again shell. In this video, I'll demonstrate how to create and edit files in this shell. At the Linux command line, we can use the echo command to display information back to the screen. Here I've typed in echo space, and in double quotes I've put in the word blue, and it returns to the screen blue. But what I can do is I can redirect that output to a file instead of the screen. So I'll use my up arrow key to bring up the previous command, and at the end I will add a greater than sign. This is the output redirection symbol that allows us to redirect output to a file. And I want to store that in a file called colors. So instead of displaying the word blue on the screen, it wrote it to the file called colors. We can verify this using the cat command. So I'll type in cat space colors, and indeed the word blue is stored in that file. This time I'm going to type echo, and I'll use the color red in quotes. But what I want to do is append it to the colors file. I don't want to overwrite the color blue that's already there. So instead of using a single greater than sign, I'll use the double greater than sign. This is the append operator. Now, when I view the contents of the colors file with the cat command, I see both blue followed by red on another line. Sometimes we want to do something a little more complex to write it out to a file. For example, here I'll use echo with the -E command line switch. I'm doing -E because I want to specify a new line character to move things on different lines. So in quotes, I'm going to type in logged in users followed by \n, that's my new line character, that's where the -E comes in. Then I want to display the result of the Linux who command, which shows me who's logged in. So the who command is enclosed within parentheses, which is prefixed with the $sign because it's in the midst of a command here. Now if I simply press enter at this point, it returns the output to the screen. On the first line it says logged in users, and then on the next line it has the single user that happens to be logged in now, which is myself, root. What I want to do is output that to a file. At this point, all I need to do is use the single greater than sign, the output redirection symbol, and give it a file name, in this case, user log. So you can take the result of any Linux command and redirect it or append it to a file if you choose. We can also edit files even at the command line. From the graphical environment, we could use the gedit tool to open up a file such as, in our case, user log. But that's in the graphical editor if we wanted to make changes. At the command line, what we might use is the VI editor. So I'll type in VI or vi space user log. At this point, I'm in a text editor and I'm in command mode. I could press the insert key if I wanted to make changes to the text within the file. And in the bottom left, it now says insert. So maybe I'll press enter and I'll type in begin at the very top of the file. I'm going to press escape to go back to command mode, then I'll type :WQ for write and quit, which we see in the bottom left. I've now made a change to the user log file and saved it, as we can see with the cat command. In this video, we learned how to create and edit files in the shell. In this exercise, you'll be working both on the graphical side of Linux as well as from the shell. From within the GNOME environment, we'll be changing the background of the display and switching to a different local console. From the shell, we'll be listing files in a directory from largest to smallest, creating a text file and then putting that file into a new subdirectory. We'll be making a link to that new subdirectory with the name of test link, and then finally we'll execute gedit from the shell to open the text file that was just created. Pause the video and then go ahead and try these tasks yourself and come back to see a possible solution. Now I'll demonstrate one way to accomplish the exercise tasks. The first thing is to change the display background. I can do that by right-clicking on the background and choosing Change Desktop Background. I can see what's currently selected, so I can click on that and I can choose from a different image. I'll just go ahead and double-click on another image to set it as the display background. We can switch to another local console with a certain key combination that will vary between different Linux distributions. Here in Red Hat Enterprise Linux, I'll press Ctrl-Alt-F3 to switch to another terminal screen on the same host, where it asks me to log in. Here, I'll log in as user C. Blackwell. So I can have multiple independent user sessions running on the same host at the same time. I'm going to go back to the GUI by pressing Ctrl-Alt-F1. Here in the command line shell, I need to list files in a directory from largest to smallest. The first thing I can do is use the man command so that I can view the man page for the ls command. This way, I can search by typing a front slash and size, for example, for how to do something specifically with this command. I'm going to press N to keep going forward through the man page until I see what I'm looking for. I now see that I can use -S with ls to view things by size. So I'll press Q and I'll go into the etc directory where I'll type ls-l-S. So I want a long listing, sort of by size, and I'll pipe that to more so it stops after the first screenful. Here indeed we can see things are now ordered from largest to smallest. I'll press Q to get out of that. What I now want to do is create a text file in my home directory. So I'm going to issue the who command and I'm going to use the output redirection symbol to put that in a file called logged in users. Of course, I can use the cat command to view the contents of that file. But it's not in my home directory, so I'm going to use the move command to move that file into my home directory. My home directory can be referenced with the tilde. I also want to make a copy of that file from my home directory, and I want to place that on the root in another directory called user files. For convenience, in my home directory, which I will change to with cd enter, I want to use the ln-s command to make a symbolic link to the user files directory that will exist here in my home directory. I want the link to be called test link. So my command will be ln-s/user files, that's the source, and I want to create a link called test link in the current location. If I do an ls-l in the current location, you can see in fact that the test link points to the user files directory. What I now want to do is use gedit to open up that file that I created. In this case, it's stored in user files. I could also use my test link to get access to that folder, but I'm going to use gedit to open up that file in a graphical editor. In this exercise, we worked both from GNOME and also from the Linux command line shell.